Can we have the next candidate, please?
Yes, ma'am. Good afternoon, ma'am.
Good afternoon.
Ma'am, should I start my presentation?
Yes, please.
Let me present. Ma'am, is my screen presenting?
Yes.
Okay, ma'am. Myself, Geet Bava, and I just joined as a research scholar at City University, Ludhiana, and currently working as assistant professor at Khalsa College for Women, Amritsar, Punjab. Ma'am, the topic of my presentation is fusion of Internet of Things and blockchain. Before discussing what is blockchain of things, I would firstly like to discuss what is Internet of Things in an as simplified way as I can. Now, what is Internet of Things? For that, I wish all of you to imagine that you are sitting in your workplace and all of a sudden you realize that you have forgotten to turn off the AC of your house while leaving for office. Now, instead of going all the way back to your house to turn off the AC, what if you could use your smartphone to turn it off? So this is where the role of IoT comes into play. Until recently, the devices like mobile phones, tablets, computers, they were connected to internet and could interact with one another. But now various objects and things around us could be connected to internet and could even interact with one another. So IoT is shaping the way we live our lives. Now, what exactly is Internet of Things? So IoT is a system of interrelated devices connected to internet to send and receive data from one another. A smart home is the best example of IoT. All the home equipments like air conditioners, doorbells, thermostats, smoke detectors, water geysers, security alarms, they can now be connected to internet and could even communicate with one another and could even be controlled with our smartphones. So until recently, the scenario was that only humans could able to interact with one another, but now the devices or things can also interact with one another. Now, for example, in the morning our alarm clock rings, IoT enabled alarm clock, and it sends the signals to IoT enabled window blind to open. And the window blind is sending the signal to IoT enabled coffee maker machine to make coffee for us, and IoT enabled coffee maker machine is sending the signal to IoT enabled electric geyser to turn on. So this was what the Internet of Things actually does. Now these are some applications and use cases. Now let me discuss the architecture of IoT or working mechanism of IoT in brief. So in the first layer we have sensors. All IoT devices are integrated with sensors. We have many types of sensors available. For example, for getting temperature data, we have temperature sensor. Similarly, we have humidity sensor, pressure sensor, and many other. So these sensors are the devices which gather physical information about the environment. But the issue here is that whatever data we are gathering using these sensors is an analog data, and we cannot directly transfer this analog data into the cloud. So the data needs to be converted into digital form. So for that, there is a system called data acquisition system, which helps to convert this analog data into digital data. The IoT gateway then ships this transformed digital data to the cloud servers. Now in cloud, data analytics comes into picture, where the collected data is analyzed and the results or the insights are transferred to the mobile device. So this was how IoT works, a brief introduction. Now what are the security challenges IoT is currently facing? The first major challenge of IoT is its centralized architecture. Presently, centralized architecture models are being commonly used to authenticate, authorize, validate, and connect diverse things in IoT. But what if this centralized server becomes unavailable or goes down or stop working? So this is the challenge that IoT is facing. The next challenge is the heterogeneous nature of IoT devices. We have heterogeneous devices, heterogeneous addressing models, formats and heterogeneous communication protocols such as ZigBee, MQTT, COAP, AMQP, Bluetooth, and many more. And this adds complexity in the network. Lack of interoperability. So this affects the consumption scope, consumption timelines, and expenditure of IoT systems. Constrained IoT resources. IoT devices usually have restricted power, processing, and memory resources due to their tiny sizes, which is another challenge. Confidentiality disclosure. So due to the complex, heterogeneous, and centralized nature of IoT, and moreover the use of third-party cloud servers provides a target-rich atmosphere for the intruders. Then a lack of authentication and authorization. Actually, it is difficult to integrate countermeasures such as authentication, authorization, encryption, decryption, firewalls, antivirus in resource-constrained IoT devices. Insufficient testing. With the increase in number of IoT devices, IoT manufacturers are more eager to produce and deliver their devices as fast as they can. So IoT products don't get enough testing and updates, hence are prone to hackers. Default passwords. Company uses factory default passwords on their manufactured devices, so placing both their business and customers at the risk of attacks. So what are the solutions to all these issues the IoT is currently facing? The answer is blockchain technology. Now, what is blockchain technology? Actually, blockchain technology was described in 1991 by a group of researchers and was intended to timestamp digital documents so that it is not possible to backdate them or tamper with them. Stuart Haber and W. Scott Stornetta published in 1991 how to digitally timestamp a document, and this was the source of blockchain technology idea. But this idea of blockchain was unused till it was adapted by Satoshi Nakamoto in 2009 to create a digital cryptocurrency, Bitcoin. Now, blockchain is actually distributed, immutable, transparent ledger. Means it is not centralized and is tamper resistant and completely open to anyone. So, blockchain is actually a chain of blocks. Block contains some data, hash of blocks and hash of previous blocks. So, data is stored inside the block, depends on the type of the blockchain. For example, a Bitcoin blockchain stores details about the transactions such as the sender, receiver and amount of coins. Blockchain also has a hash value. Hash can be compared to the fingerprint that identifies a block and is always unique. Once a block is created, its hash is calculated, and changing something inside the block will cause hash to change as well. So this adds to the security of blockchain. The third element of blockchain is hash of previous block, which effectively creates chain of blocks and make blockchain so secure. So blockchain looks like this. Block number 3 is pointing to block number 2, 2 is pointing to 1. The first block of the blockchain is called Genesis block. Now, what if someone wants to tamper the second block, for example? So what happens? This would cause hash of second block to change as well, which makes the block 3 and the following blocks invalid, because now they do not store valid hash of previous block, making it noticeable and hence tamper proof. Furthermore, the consensus mechanisms add safety to the blockchain technology. Now, due to the time limitation, I won't be able to discuss the consensus mechanisms. Now, the question is, what are the benefits of fusion of these two technologies, blockchain and IoT? The first is decentralization. Blockchained IoT would be a decentralized ledger which resolve a single point of failure issue and issue of spending too much on third-party cloud servers to store data. Immutability. Blockchained IoT would be an immutable data structure where any modifications in the data must be validated by the majority of nodes making the system to be too safe and confidential. Identity and access management. This will secure IoT data from threats like DOS attack, DDoS attack, IP spoofing, and many other. Reliability. The hash function technique in blockchain and the cryptographic methods and the digital signatures would make blockchained IoT very much reliable. Trustfulness. Since IoT data, when is stored in blockchain, is encrypted using keys, data remains secure and trustworthy. Moreover, smart contract features of blockchain would help IoT data to build a strong trust. Traceability. Blockchain IoT would allow traceability of a product from its origin to handing over to its customer. And other benefits include anonymity, autonomy, interoperability. So these are the use cases of blockchain IoT technology. So all the IoT fields would be guarded with the benefits provided by blockchain. Data from smart cars, smart farming, smart gadgets and others would be safe, secure, immutable and trustworthy using blockchain technique in IoT. So the possibilities of blockchain IoT are infinite. Thank you and have a nice day.
So, ma'am, I have one question for you. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay, so the question is, like you already mentioned, security is a major concern in IoT.
Yes, ma'am.
Because it is more prone to hackers for any kind of hacking sort of a thing.
Yes, ma'am.
So how do we overcome this challenge?
Ma'am, we can store the IoT collected data in the blockchain. Because the blockchain is very secure in terms that if anyone tries to change the data in the blockchain, that is immediately noticeable. Because here, due to the consensus mechanism, the decision of the majority is accepted. So if a hacker tries to change a block in one blockchain, but the majority is saying that no, this is not a valid blockchain. So what happens, the blockchain is reversed and it is made to what it actually should be. So I think if IoT is merged with blockchain, then it would be more secure. Because ma'am, I have read somewhere that in like few years back, 2 or 3 years back, there was a DINE attack using IoT devices on the websites like Twitter and Amazon. And this attack was done using the IoT enabled smart cameras. So if we use blockchain in IoT, then the security of IoT devices would definitely increase.
Okay, thank you.
Thank you so much, ma'am.
The next candidate, please.